Example 1 on the arithmetic series is taking a look at the arithmetic series in practice. And what we're told here is that John is training for a marathon. Last week his furthest run was 4 miles, and he plans to increase the length he runs by 1.1 miles per day. So this tells us that we're using an arithmetic series here because it's increasing by the same amount each day. And simply all we have to do here is find the total distance that he's run by the time he reaches his goal of 26 miles. So what we need to do here first is write down the information we've been given in the context of this question, and then we're looking to calculate the sum here of the total distance by the time he reaches his goal of 26 miles. So first let's write down what we've been given. Well, what we've been told is the first term here was the furthest run in that last week, which was 4 miles. So we can say A, the first term, is 4. We know the increase for each day is simply 1.1 miles. That means the difference here is 1.1. And in this case then, the last term we've actually been given, that's this 26 miles here. So in that case, we can write down the last term as being 26. And what we're looking to do here is find the sum of the first n terms. So what we need to do now is actually work out how many terms are between our first term here, A, and between our last term, which is this L here. Okay, so how would we do that? Well, if we want to calculate n here, what we need to work out is essentially how many days he's running for. And if we notice that they're increasing by 1.1 miles, and we start on 4 miles then, and we go up to 26, well, we can simply calculate n then as being 26 minus 4, what we started with here, so what we finished with, minus what we started with, and then divide this by the increase of 1.1. And if you do this, what you obtain here is 20 for n. But we have to be slightly careful here. Remember, we need to include the first day, which is 4 here, and we also need to include the last term as well, which was the last day, which was the goal of 26 miles. Well, we've already included the 26 miles here, so in that case we also need to include the first day, which adds another 1 onto our n here. So therefore n is actually equal to 20 plus 1 here, because we need to include the first term. So therefore n is actually 21 here. So now using our summation formula here, so using Sn is equal, and in this case, because we've been given the first and the last term, and the common difference here of 1.1, we can simply use the simplified formula here, which is n times a plus l divided by 2. Obviously, if we didn't have the last term here, we would have to use the extended formula to calculate the sum of the first n terms there. And all we need to do now is simply substitute our appropriate terms in. Now we want the sum of the first 21 terms here, n is 21, so therefore we're looking for s 21, which is going to be equal to n, which, like we just said, is 21, times by a plus l. Well, a is 4 and l is 26. And we divide this by 2. And simply all we need to do here now is start simplifying and evaluating the sum of the first 21 terms. So this is going to be 21 times 30 divided by 2. And 21 times 30 would give us 630. So this is 630 divided by 2. And 630 divided by 2 will give us 315 as our total distance there. And as he's running in miles here, 4 miles, and his goal is 26 miles, then his total distance is 315 miles there, if we include our units. Okay, so that gives us our solution there to example 1, taking a look at the arithmetic series in practice. Example 2 here on sequences takes a look at sum notation. So we need to be confident with this idea here of this sigma notation and what this represents. And like we can see, this just represents the summation of a number of different terms in this sequence. And what we'll do here is just write down the first few terms just to get an idea of what's actually happening with this sequence. So the first term here, well, that's obtained when n equals 1. So it's going to be 3 times 1, we just substitute into this expression here. So it's 3 times 1, giving us 3, plus 4 gives us 7. The second term then will be obtained in a similar manner, simply replacing n with 2 here. So we obtain 3 times 2, which is 6, plus the 4 gives us 10. And all we'll do now is just find one more term here, which is the third term. And if we do that again, repeating what we've just done with the first term and the second term here, simply substituting n equals 3 in, we obtain 3 times 3, which is 9, plus 4, giving us 13. And you might notice here straight away that this is actually forming an arithmetic sequence or series. So in this case, if we start with 7 and add 3, we get to 10. If we take this 10 and add 3, we obtain 13. So in this case, this forms an arithmetic series. And simply, if we want to find the sum of the first 50 terms here, we can simply form this using our summation notation and formula. Now here, we can simplify this a little bit. So let's note down what we've got first. We've got a, the first term, which is 7. We've got the difference, which is increasing by positive 3, or increasing by 3. We have the number of terms, that's n, which is equal to 50. Now here, there's two formulas we can use. If we don't have the last term, we have to use the slightly extended formula, so we'd be using, in that case, Sm is equal to n over 2 of 2a, or times 2a, plus n minus 1 times d. Okay, we would use that if we didn't have the last term, but we could also easily calculate here the 50th term, which is our last term. Okay, and again, we simply obtain that by substituting n equals 50 into this expression. And if we have the last term, we can simply use Sm is equal to n times a plus l, all divided by 2. Okay, either of these formulas here, if used appropriately, will give you the correct solution of this summation. So I'm going to simply calculate here the 50th term, which again is obtained by substituting n equals 50 into this expression. So that's going to give us 3 times 50, which is 150, plus the 4, simply giving us 154 there for our 50th term. Okay, and all I'm going to simply do now is use the fact that the last term is 154 and use this formula here, okay, for our summation of the first 50th terms. So in that case, this is going to be S50, and it's going to be equal to n, which is 50, times by a plus l, so that's 7, plus 154, and then we divide this by 2. All we need to simply do here is evaluate this expression. So this gives us 50 times 161. We divide this by 2, and then evaluate this here to simply obtain 4,025 there. Again, you could have used this formula here, but this one here is slightly quicker. But either way, that gives us the solution there to example 2 on summation notation.